Okay, 39 is a good problem that involves calculating the rotational inertia of an object or of a group of objects, sort of different objects. So that will be helpful for at least a couple problems in your homework. So what it is you got that, and we'll just leave that there. And then over here you got a rod and a little ball-shaped object, another rod and ball-shaped object. The mass of the ball, each ball is little m. The mass of each rod is big M. The length of each rod is d. And it's rotating around like that with an angular speed of omega. These givens are all given in the book, and I'll just plug those in. You can read along, but I'll plug those in later. So, to figure out the moment of inertia of this group of objects, you really just got to do the moment of inertia of each individual object, and then add them up. So we got the total moment of inertia equals the moment of inertia of rod 1 plus the moment of inertia of the mass 1, this little guy here, plus the moment of inertia of rod 2, which is the second rod, and finally the moment of inertia of the second mass, second little ball here. Alright? Now for a rod, you know the moment of inertia is 1/12 times the mass times the length squared. But notice that it's pivoting at the end here. So we'll have to do parallel axis theorem, and the distance from the center of mass to the pivot point is the h in the center of in the parallel axis theorem. So we go plus mh, we'll say mh1 squared. So later on I'll plug in h as this distance. Then this is just a point object, so I'm gonna sneeze. Hold on. I shouldn't have said anything. I jinxed it. All right. Anyway, so this is a point particle. So the moment of inertia of a point particle is just m. We'll say r1 squared, where r1 is the distance from this point particle to the pivot. Plus, now we got another rod, so 1/12 md squared plus mh2 squared, where h now is the distance from this center of mass to this pivot point. So, and finally mr2 squared. Not too bad. So this equals 1/12 md squared plus m. This is d over 2 squared because this distance is half of d, plus md squared, this is a distance d away, length of the rod here, plus, don't need parentheses anymore, 1/12 md squared plus m. Now this is 1.5 d's away, right? 1.5, so that's 3/2 squared plus m, and this one is 2d's away. 2d squared. And a little bit of simplifying. These two make 2/12 or 1/6 m d squared, so took care of those. This one is just m d squared over 4 plus md squared. So those are taken care of. Plus 9m. Oops, I forgot the d in here. D. 9m d squared over 4 plus, this should be a big M. Oh, I messed up. This should be a big M. Right, because this is parallel axis theorem of the rod, so these are both for the rod. So big M, little m, big M, little m. Alright, good. So big M, little m, big M. This is, yep, plus little m times 4d squared. Took care of that. Alright, so I got all those. Now, let's combine the big m's. We got this one, and this one, and this one. This is a big M. So this becomes a sixth. So what do they got in common? They got basically 12 in common, right? So this is 2 over 12. Should have just left it. 2 over 12 md squared plus this is 3 over 12, and this is 18 over 12, and that's 23 over 12 md squared plus, and then the little m's, we got 4, 5 of those, little md squared. And then from here, you can, hold on a second, am I missing something? Yeah, this is 9 times 3 is 27. This is 32. Probably should have stuck with my notes. It's getting all cocky and trying to do it in my head. Yeah, anyway, so yeah, 32 over 12 md squared plus 5 md squared. And so then you plug in your values. Big M, if you look in the book, is 1.2. This 32 over 12 simplifies to 8 over 3. And then big M is 1.2. And D is 0.056 squared plus 5. Little m is 0.85, as can be seen in the book. 0.056 squared, and that equals 0.0234 kilogram meter squared. So anyway, long story short, you just add all of the individual ones where we needed parallel axis theorem for the rods because they weren't pivoting at the center of mass, and just a slight smidgen of algebra, and you got it. So to do that's part A. To do part B, which is asking for the kinetic energy, that's just 1/2 I omega squared. You just plug in the I we found, 0.0234, and the omega given was 0.3 squared, and that gives you the answer of 0.00105 joules. Alright, so the next problem I'll do is 48. Later!